Alright, in the previous video we saw how we could actually sketch straight lines on the Cartesian plane simply by finding the y-intercept and the x-intercept of the line. And we also saw how we could actually do that by simply looking at the equation of the line and then just selecting the values accordingly. That would give us those intercepts. Now in this video we're going to do some exercises of sketching those straight lines based on the equations. But you will notice that in this case, the equation is not expressed in the usual form y equals to, say, ax plus b. So you'll notice that in this case, we have an equation that has both x and y on the left-hand side, or it could have a combination of constants and so on. So in order to plot it first, we need to rearrange the equation so that it looks like a little bit more like this. Now, I guess a really good point that I should make is that there are two choices that we can take, that we can make when it comes to rearranging an equation that looks like this or that. And it is that we can either rearrange for x as a function of y or y as a function of x. So what I mean is that we can express x in terms of y. If we, for example, subtract y from both sides, we could write something like x is going to be equal to 2 minus y. So that's a perfectly valid equation because it means that if we were to plot this on the Cartesian plane, we would actually be looking at this set of axes from this direction. So basically, it would be like you were tilting your head on a 90-degree angle and you're looking at the x-axis as if it were the vertical axis, and then y would be the horizontal axis. So if we were to talk about independent and dependent variables, in this case, the independent variable would be y because you can select any value of y that you want and it would allow you to calculate a value of x. So the equation of the line would still be the same, but it would be like looking at it from a different angle. Now, generally, we prefer it in this way because it is mathematical tradition to always draw the y-axis vertical on our piece of paper, and then the x-axis is horizontal. So that's why we prefer to just express equations in terms of y. So if we wanted to write the equation y as a function of x, all we need to do is we rearrange for y. So in this case, we subtract x from both sides. So that's going to give us the equation y equals to 2 minus x. Okay, so those two equations, these three equations are the same. They all represent the exact same straight line on the Cartesian plane, but this one is looking at it from this perspective. This one is the conventional way, where you're looking at the y-axis as if it were the vertical axis, which is our case here. That's a human eye, by the way, so I'm not very good at drawing eyes, but hopefully you can see that it's basically like looking at the axis in this direction. Now what we're going to do is we're going to take the form of the equation that looks like this, and we're going to find two things. We're going to find the y-intercept and the x-intercept. So let's start with the y-intercept. Y-intercept occurs when, so let me just write it here. Y-intercept occurs when x equals to 0. And therefore, if we make x equals to 0 in this equation, y becomes 2. So the point that we should be looking at is the point 0, 2. Which would be somewhere here. So let me just mark it there. That's y equals 2. The x-intercept is going to be the point at which y is equal to 0. And therefore, we need to rearrange this equation. So we're going to have 0 equals to 2 minus x. And then we rearrange it for x. So x is going to be equal to 2. And that means that the point we're looking at is the point 2, 0. So that's going to be somewhere here. Okay, so now all we need to do here is we draw a line that passes through both of those points, and in this case the line is going to be steep in this direction. Normally we would see the lines in this direction, but in this case it's going this way. And we will find out a few videos later on that the reason why the line is now pointing in this direction, basically if you were to place a little sphere or a disc on top of this, it would roll in this direction rather than that direction. The reason for that is that the coefficient attached to the x is negative. If the value of x is negative, or basically the coefficient next to x is negative, then the line will always be pointing in this direction. And that's something that we're going to discuss a little bit more in detail a few videos later on. For now, we're going to focus mainly on just drawing these lines on the Cartesian plane. Okay, so that's our line. That's pretty much it. Now let's move on to the next example. We have this equation. Once again, we are expressing x and y on the left hand side, so we need to rearrange it. As I mentioned before, we usually prefer to express everything as a y in terms of x, so we just rearrange for y. So one thing we could do in this case is we can subtract 4x from both sides, so that leaves us with minus y equals to 8 minus 4x. And now we could just multiply both sides by minus 1, such that the left hand side becomes positive. That's 8 minus 4x. Actually, this is going to become minus, that's going to become plus. And now we can divide both sides by 2, so this is going to be y. And I'm going to rearrange this so that the x is on this side now. So that's going to be 2x minus 4. Okay, so now we find the y-intercept and the x-intercept. So y-intercept occurs at x equals to 0, and then that's going to be y equals to minus 4. So the point we're looking at is going to be 0 minus 4. And the x-intercept is going to be y equals 0. Then we're going to have 0 equals to 2x minus 4. We rearrange the equation for x. And hopefully at this point you should be more comfortable with rearranging equations. So that should come out to x equals to 2. So the point we're going to look at is the point 2, 0. Alright, so now what we're going to do is we're going to draw our Cartesian plane here. That's x, that's y, and we have the point 0, that's the origin there. And now we're going to start, so the y-intercept occurs here, so that's going to be below the x-axis. And the next point is going to be at point 2, 0. So now we're just going to draw a straight line that passes through those 2 points. And that's it. That's our line there. You can see that this one is a lot steeper than the first one. So the first one, you can see that as you move 2 units to the right, you're actually going down by 2 units as well. So it's actually a 1-to-1 ratio when in terms of descent to advance in the horizontal direction. In this case, as you move 2 units to the right, you're actually going up by 4 units. So it would be a 2-to-1 ratio in terms of that. Now what we're going to do is we're going to solve this one. So same procedure again. It's very straightforward. We're going to rearrange the equation in terms of y. So let's subtract 2x from both sides. Minus 5y equals to minus 10 minus 2x. Now we're going to have, let's multiply both sides by minus 1. So this becomes 5y equals to 10 plus 2x. And that means that y is going to be, divide both sides by 5. That's 2 on 5x plus 10 divided by 5 is 2. Okay, so now with that, what we're going to have is the y-intercept. X equals 0, so y is going to be equal to 2. So that's the point 0, 2. X-intercept is going to be the point y equals 0, which leaves us with the equation 2 over 5x plus 2. And now we're just going to rearrange everything in terms of x. So we can multiply, well, we can move the 2 to the other side. So that's going to be 2 over 5x equals to minus 2. We can multiply both sides by 5. So that's going to be 2x equals to minus 10. And now we divide both sides by 2. So that's going to be x equals to minus 5. And that corresponds to the point minus 5, 0. So once again, we draw our Cartesian plane, x and y axis. Never forget to label them. It's very important that you always label your axis. And now we have the origin there. So the first point occurs at the point 0, 2. So that's going to be somewhere over here. The second one is when x equals to minus 5. So that's going to be to the left here. And then basically that's the second point. So now we know what this equation is going to look like. So it's going to look something like that. And notice what I mentioned at the beginning with the rolling sphere or disk and the steepness of that line. In this particular case, the coefficient of x was negative, which means that it's pointing in this direction down. Whereas in the second equation here, we notice that the coefficient next to x is positive, so it is pointing in this direction. So if we were to place a disk on top of that, it would actually roll in this direction. And now, for question C, we have the same situation again. If we place a disk here, it's going to roll to the left. And basically, that's because the coefficient of x is positive once again. So you're going to get used to that, and you will be able to tell from the equation itself whether this line is going this direction or that direction. That just comes with a lot of practice, but you will get there, don't worry. Alright, so next one is going to be this. This one is a lot easier to rearrange because we know, okay, so we could add y to both sides, so we're going to be left with y equals to 2x minus 4. So that's already the equation itself there. And now what we're going to do with this is we're going to find the y-intercept. So that's x equals to 0. We find y equals to minus 4. And I believe that would be, isn't that? It's the exact same one. Yeah, that's really strange. I didn't notice I had the same example. So let me just quickly change this to something a little bit different. So how about we make it 6? So if we make that 6, then that means that the y-intercept would be at minus 6. And then the x-intercept is going to be at the point y equals to 0. And then x is going to be, well, we need to rearrange the equation, right? So we're going to have 0 equals to 2x minus 6, such that x equals to, so add 6 to both sides, so this becomes 6 equals to 2x, and then divide both sides by 2, so x is going to be 3. So this point is going to be 0 minus 6, and this point is going to be 3, 0. And before I draw the line, can you guess in which direction that little disk is going to roll? Just by looking at the equation. So let's find out. So the first point is going to be somewhere here. The second point is going to be here. Now we're going to join those 2 points. And if I place a disk on top of this line, we notice that it is going to tend to roll in that direction. And that's expected since the coefficient of x is positive again. So hopefully this video has helped you gain some more intuition into how to draw these lines based on the 2 characteristics of the line, which are the y and the x-intercept, and then how you can manipulate the equations around just to get some more insight into the relationship between the 2 unknowns in this case.